Hello everyone, this is Ümit Alkuş. In this video, we will solve one problem in chapter 3. Three vectors A, B, and C are given in a Cartesian coordinate system. Vector A has a magnitude of 3 meters, lies in the xy plane, and is directed at an angle of 25 degrees from the negative x direction. Vector B lies in the xy plane and is given by B equals 3I hat minus j hat meters. Finally, vector C is along the negative z direction and has a magnitude of 3 meters. A. Write down vectors A and C in unit vector notation. B. What is A dot B? Find also the angle between vectors A and B. What is D equals A cross C in unit vector notation? Find also the magnitude and direction of vector D. Show explicitly that the angle between vectors A and D is 90 degrees. First of all, we write the given quantities in SI unit system. In part A, we write down vectors A and C in unit vector notation as follows. Now we put the numerical values into the equation. Therefore, we have. Note that in this middle result, we use 5 significant figures. So, vector A is approximately minus 2.72 I hat plus 1.27 j hat meters. And vector C is simply minus 3.00 k hat in meters. In part B, we find A dot B and the angle between vectors A and B. We can write A dot B in terms of their components as AX times BX plus AY times BY plus AZ times BZ. If we substitute the corresponding numerical values into this equation, we get. Note that in this calculation, we use the mid result for A, that is, 5 significant numbers. Therefore, we obtain negative 9.4246 meters squared, which is the 5 significant figure mid result. And the final result is approximately negative 9.42 meters squared. Next, we find the angle between vectors A and B. Let's denote it by theta AB. It is calculated by the formula arc cosine of A dot B over A times B. Now we substitute the corresponding numerical values into this formula by calculating the magnitude of B as 3.1623 meters. As a result, the angle between vectors A and B is found to be approximately 173 degrees. Okay, that's all about part B. Let's solve part C. Vector D is given by A cross C. If we put the corresponding values into this equation, we get. From the property of distribution, we get. Remember that I hat cross k hat is equal to minus j hat, and j hat cross k hat is equal to I hat. Therefore, we write the middle result in 5 significant figures as. Then the final result is approximately minus 3.80 I hat minus 8.16 j hat in meters squared. The magnitude of vector D is found by this formula If we calculate, we obtain 9 meters squared. And the angle from the positive x-axis to vector d is found by this formula, so that we obtain 65 degrees. However, since vector d is in the third region, we add 180 degrees to this result. Therefore, direction of vector d is found as 245 degrees. To find the angle between vectors a and d, we use the following formula. If we insert the numerical values into this equation, we find that it is 0. Therefore, the angle between A and D is 90 degrees. Okay, this result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.